if you go to idle, if you find the listings, unzip them, drag them out of the zip folder onto your desktop, and right-click on the listing and edit with idle, then it'll open it up so that you can actually see the listing. If you just double-click on it, it'll just run the program. So in order to see the listing, right-click on the listing, and it will open it up in idle. And you should see something like this. So what I do is, here's the zip file that I got from that site. I opened it up. I just dragged chapter 3 out onto the desktop. And once I had chapter 2 out of the desktop, once I had chapter 2 open, then I had these listings. If I click, for example, on this listing, it just runs it. If I right-click on it and edit with idle, it should open up. Did that work for everybody?
Yeah, not me. I was trying to go back to it. Go to Blackboard, go to assignments.
Yes. Oh, no, go to learning modules. And then day 3, and then there's the zip file. So when I have sample programs, that's what we'll do is you just download them, unzip them. You need them to be unzipped, makes it easier. And then just to see the listing, you right-click and look at item. Did that work for you, Victoria? Good. So then if it doesn't work for you that way, you can also open up an idle window first, and then you can then browse to that program. So the other way was what I could do is I could here I am in idle. I just go to File, Open, go to wherever that file is, and that will open it up too. So you can either open idle up first and use the file and browse to it, or you can right-click on it and open in idle. Does that make sense? Question? When I would, yeah, actually that should work too. You would right click and extract all. No, it's in the desktop. So cancel all that. Then I can change the location. So close that, right click again, extract all. And that should be fine. And then right there, now you're getting, it's actually right click on the first page. Do that.
Thank you, sorry about that.
Okay, good. It's already. Yeah. Okay, cool. So then you just go to your file window. Yeah, go to the file. And we should be able to find it. Cool. I think we're all in sync. So, that's how you can open up your programs after you've written them. And you'll see that this one has, you'll know at the top, you can see that there's a comment. This number sign, any line that starts with a number sign, the interpreter will ignore all the characters after that. And you may think, well, why do we need a command that tells us to ignore everything? This allows us to make comments. So You saw in the instructions, I said put some comments at the top, and I actually saw that my sample comment had all these number signs at the beginning. That's the format that I recommend for the top of any program you write from here on out. And in fact, if you write a program, you always want to put on every file that you do, you want to put a comment block like that that says who you are, what your contact information is, and what it is you've built. Because you may, especially if you're working on an open source project or you're working on the team, that gives you credit for the work you've done. And so you want to take credit for it, and it also helps them know who to talk to if they have a question about the code. So here what we have is we have a variable called months. And we can see here that we have equals open square brace, and you see all these strings are in here separated by commas. And then close with another square brace. Square braces designate a list. And this is a list of strings, which actually makes it a list of lists, because, or a sequence of sequences, because a string is a sequence as well. A list is a sequence, and so this is a list which contains a sequence of strings. Make sense? And so we can very quickly make a list like this. And this is why we can initialize it. And so further down in your code, if you look at it, you'll see a list with a comment says a list with one ending for each number from 1 to 31. And so what they did here is they had a sequence that says STNDRD plus 17 THs. So this is kind of interesting. What's going on here? Well, what they're doing is they're making this list of endings so that, you know, when we say first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. When you get to, the reason why there's 17 is 17, 18, 19, 20, 21st, 22nd, 23rd. The rest of them are THs until you get to the next one, until you get to 31st. So that's why making a sequence where each element is the correct ending for that number. And there's some weird things going on here. Here we have, obviously this is a list of strings, but then we have a plus. You think we're adding the number 17 to each of those elements. No, what we're really doing is we're saying 17 THs. So we're taking a list of one item called a TH, and when we multiply by 17, it will create 17 of those. And then we're taking and put that all into one list of 17 THs. And then we're taking that list of 17 THs and we're adding it to this one. So now we have ST, ND, RD, and 17 THs. If you need to split your code up along multiple lines in Python, you have to use this / And that way it knows to just treat this as if it's all one big long line. Otherwise, you'd have to write your code, and it's really painful to read because you have to scroll all over. So after it does this 17 THs, it then says we're going to add another sequence, STNDRD. And so it adds that to that whole list that we currently have. And then it says we need 17 more THs, so we multiply TH by 7. That gives us 7 of those. We concatenate that onto the list. And then finally add an ST on the end. And that will make this whole list of all these. This will make one list, and it will have 31 strings in here. Make sense? And then here, we get the year from the user, we get the month from the user, and the day from the user. Notice that in parentheses, it's telling the user what format they want the input from. Very important when you're asking input from users. Oddly enough, users tend to not do exactly what you tell them to do, but at least we try to help them out a little bit. And then here, notice that they're figuring out the month number. We have a month, and they're converting it to an integer. So the month comes in, with raw input, it always comes in as a string. And so we can't really treat that as a number until we do this type conversion. And we do the type conversion by saying the type, and then in parentheses what we want to convert.
What if you drop the raw and you just use input?
That would work too. Then you would not need to do this conversion. You'll often find in Python, most people will bring everything in as a raw input and do the conversion. And the reason is because we can actually do validation on that string before we do the conversion. So you could actually, later on, we'll learn to do, we'll do exception handling and some other things to do validation. We want to keep it simple at this point, so I'm not going to require validation. But you could actually have a bunch of code that would check that and validate that it was actually a valid number before it would actually do the conversion. So that's why you see this pattern happen a lot. So now we've got this month as an integer, we've got this day as an integer. And it says, remember to subtract 1 from month and day to get a correct index. Why is that? We start at 0. Humans start at 1. So we often find ourselves getting input, subtracting 1, and storing an index that's 0 based. Or in this case, they just did it at this stage. And so we're going to say the month name, so the user's going to put in the month as a number, and then we say month name equals months, which is here are months, and we have, what's the index of January?
0.
0. The index of January is 0. So we subtract 1, so if they put in a 1 here, we'll get a 0, and month name will then get what? January, the string January. Ordinal equals day plus endings. So day, we get 1 through 31. That's just going to be the string that they put in, which will be 1 through 31 presumably. And then it needs the ending. So to get the ending, it takes a day minus 1. And so if they put in the day is 1 for the first, which ending does it grab?
First.
Which is this ST, right? If it is the 8, if they put in an 8 here, which ending will they grab?
GH.
It's one of those THs, the 17 times THs that they will grab. And so then they will get that ending, and so then if it was an 8, let's say 8 for the day. And the way you can think of those endings is, the computer is literally doing this. It's going to take a little bit to write it out, but I think it's useful to say. So it's going to say, I've got an ST, and then the next element's going to be a ND, and RD. So it starts off with that. And then it says, okay, I need 17 THs. So I'm going to create these 17 THs and add it to this. So then I get TH1, TH2, TH3.
I got it. 4th, 5th, 6th, 7th, 8th, 9th, 10th.
Makes sense? And then it says, now I'm going to add another ST, ND, and RD sequence. So here's where the THs continue on to the first. So at this point then, it says I have an STRD and D sequence, so it just adds that. And then TH1, TH2, TH3, so seven more of those. And then it says I have an ST at the end, and then I finish my list. So the computer will take that code and build this one list. Does that make sense?
That's only on the 31st.
Yes, that's 31. That will be 31 strings which are in that list. And so now when we go and say, grab the ending of that day, it just goes, I only want the fifth one. 0, 1, 2, 3, 4, index 5, which will be the sixth element to be that TH, or however. Make sense?
Absolutely no.
So, looks complex, but if you look at the code one piece at a time, you can kind of, and you do kind of have to say, where do I start with this? Well, multiplication is first priority. I'll probably start here. Okay, now I got a list of 17 pictures here and 7 of those. Oh, and then I'm adding these together. Doesn't make a list of 1, 2, 3, 4, 5 lists. It makes one list with all these individual elements in. So down below, after we do all that, remember to subtract 1, we get the last thing it does is it says print month name plus the ordinal plus a comma plus the year. So month name plus a space plus the ordinal plus a comma plus the year. And we'll often see this pattern too. We add spaces in with just single quote, space, single quote, because we want to spread out the words. Now, if you click on run module, or you can also use the shortcut key F5, it'll actually run that program. And if anytime you make modifications, this will pop up sometimes too. Say before run, you need to click OK. And it'll sit there with the year. And if you put 1970, it'll ask you month. If you put 1 and day 1, what do we think is going to be displayed before we hit enter? What's that?
January 1st, 1970.
Yeah. Do we get that?
January 2nd.
It came with January 2nd? That's all right. Maybe there's a -1 missing in that program.
What was that? Put 1970.
1 and then
1. Yeah.
So, kind of work. So that's actually not a bad program. You know, sometimes you want to display the date kind of a long format, but you store it as data in numbers, and that would be a program that would kind of do that for you. Make sense? There's a link here to Unix time. Gives some information about time. So, next thing I want to look at is slicing. So let's say we create this string, and we're going to call it tag, and it's actually, this is just a string. It looks confusing, but it's just a string. We got a beginning single quote and an end single quote. In this case, this is actually, if you know HTML, this is called an anchor tag. So it's just a string with some characters in it at this point. But the characters in it actually correspond to an anchor tag in HTML, which is how you create web links. This will actually be a link to the Python website. But you know, sometimes a common thing here is we want to access something. We don't want all of this extra stuff. Maybe we just want the HTTP to the org part, right? Well, we can get that by using something called slicing. And here, notice before when we had the square braces, how many numbers do we have in there? Just one index, right? Well, here we have 2 indices. We have a 9, we have a colon, and a 30. What do you suppose that 9 and 30 mean?
9 and 230 in columns.
Yes. It means start at 9 and give me every character, every element all the way to 30. But in Python, it's it's always inclusive of the first number, exclusive of the last number. So the element at index 30 will not be included in the result. So inclusive, first element, exclusive of last element. And you'll see that pattern repeated throughout Python. So it is 9 through 30, but it doesn't really show you 30. And if you look at this, 1, 2, 3, the spaces count 2, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And the 9th element is the H. If you were to count all the way to 30, it will be this last double quote, and it won't include that. Index 30 will not be included in the result. And if you do that, you'll still get a single quote on either side. That's because Python is resolving that into a string and is putting quotes on the end, but it actually didn't pull out those quotes. That's why they used the double quote as an example, I think. So it's all these elements that actually pulled out. So you can use slicing to say, take a string or any kind of sequence and grab the elements you want. Does that make sense? In this case, probably the reason why you would do it is because you wanted to just maybe display that on the website. Maybe you're presenting some information on in some application and say this is the website to go to if you want to get, for example, Python information, and I don't want to show them /a href equals, and I don't want them to have the rest of this stuff here. So I just want to grab a little piece of a string. You might do this, for example, let's say that you ask a person to type their full first, middle, let's say you have, actually more typically, you're grabbing some data, like someone's Excel spreadsheet that they created at their office, and you have to port all this data into a database. And they sort everyone's name as Robert J. Garner. And they're consistent about it, so the data is clean and good, you can use it, but you just want to grab the first name, then you want to grab the middle name, and you want to grab the last name and throw them into 3 separate fields in your database. Well, you can use, along with some other search things, you can use that slicing to grab the elements you want and then port it into the data. So we can use this to clean data. You may have beginning and ending characters that you don't want. So you could do, for example, if you did 1 and -2, or 1 and -1 because it's exclusive last one, you could actually trim off the beginning and last character or something. Let's say that there's there's some kind of delimiter they have on a piece of text you're looking at, and you want to clean that. You can use this slicing to do a lot of that type of stuff. And so Python is actually pretty good at doing web scraping and doing other kinds of things because of this ability to kind of slice through data, or slice through information. Make sense? And you can see here, the 30 corresponds to the double equals. It's exclusive, so it ignored that. But the 09 was the H, and it included that. The inclusive, not inclusive, or exclusive. You say tag 32 to -4, it's going to grab from the 32nd element. If that was 30, that's 1, that's 2. So P is the 32nd element. -4, which element would that be? Less than sign. And then that gets Python website. So maybe I just want to store this piece and that piece in my data, or I want to display that piece in that place in an output state. Make sense? So type this in, numbers equals 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. What's the significance of that sequence of numbers? Anyone know?
Add the previous number to the
Addition.
Yeah, it's called the Fibonacci sequence. It's a famous sequence in Renaissance art.
And nature spirals.
Yes.
Yeah.
Yes.
And so basically that sequence is you take the previous 2 numbers and add them together. And so 0 and 1 equals 1, 1 and 1 equals 2, 2 and 1 equals 3, 3 and 2 equals 5, etc. So you want to access the last 3 elements of a sequence. Everyone got that? So what will 7:10 return? $13, 21, 34. Did anyone get that?
Yep.
And that's how it should do it. It should, 7 is inclusive, that's the seventh, the item at index 7 is inclusive, the item at index 10 is exclusive. And we went off the end there in order to get the last one, so we had to go one more. Everyone there? Now let's try numbers of -3 : -1. Good question. Why do I not get the 34? If I wanted 34, well, -1 is always is indicating the last element, right? And it's exclusive of whatever's in this slot, right? So it can't grab. So I can't use -1 to grab the last element. So how do I get the last element using that approach?
And,
Well,
or if we're going backwards?
yeah.
Lost.
If I put a 0, it's going to grab the 0th element, right? Yeah. That would actually be probably a good syntactical approach if they design it that way. But yeah, it's problematic. You can't access the last element that way. And you know, the 10 works great if we know exactly how many elements are there. But let's say we're bringing in a sequence that's from a like a raw input, and we don't know how long this thing is. That kind of, we'd like to be able to get that last element. And we know that that doesn't work, right? Try that and see what happens. You get an empty set? An empty list?
Yep.
And so if you have a square brace and a closed brace, it's an empty list because there's nothing in it. All it does is says, okay, let's go from the -3 element to the 0th element. I'm going to start here, and then do I go forward? No, I can't go forward because the last number is back there, so that means nothing. So it returns an empty set. So that doesn't work either. Now try -3 : and put nothing there. That work?
Just end it.
Yeah, just colon and then
That's
close
it.
brace.
So don't mention that.
Yeah.
Don't mention the last part, you got it.
What this says is go from this element all the way to the end. And so that's how you get the end. Make sense? And so that can be useful. You know, you can say, I want everything from here to the end, or I want 3 elements back all the way to the end. And you can see that this is making very concise notation to grab the stuff you want from a list. So Python is kind of really good at processing lists. And you can imagine from a programming perspective, we probably do a lot with lists, right? Or sequences. So that works. Any questions? What happens if we just do that? What do we get?
I'm on.
Yeah. You get them all. It just says get everything from the beginning all the way to the end. So you can, you could do everything from the beginning and then put a number on the right side, and that would give you everything up to a number, or you can go the other way too. And you can kind of see it, they kind of organize it pretty intuitively once you kind of understand what's going on. So Python is sometimes it's kind of like, I don't know if this is right, but I'll just type some stuff in and see if it works. And yeah.
With you splicing, you have to pretty much know the length of whatever field you're trying to splice.
Well, you need to know how many characters you want from one end or the other. So I can add, this actually says, starting at the -3 index minus from the right side, grabbing all the elements from there to the end. And you don't even necessarily need to know how many elements are in that list.
I mean, I'm trying to think of it in practical use, though.
So, for example, let's say we want to get the last name, and we haven't gone over how you find a character in that. but or let's say we know that the last 5 elements of a serial number is the one that we want to store, or last 4 digits of, we want to get the last 4 digits of someone's social security number, because that's what we're going to use as their kind of semi-unique identifier for some kind of purpose, or pretty unique identifier. But what you would do is you would just go -4 : empty space.
Yeah, but that's because you already know the length of that field, though. You know that's 9 characters.
Well, let's say, yeah, and I'd have to
Like,
come
say
up
you're
with.
saying someone's last name, now that varies from 2 to.
Yeah, and I wanted the last 3 characters of their last name for some unknown reason. I could say -3 : that, and I get the last 3 characters of their last name, no matter how long their name was. And so,
Yeah, I was just trying to think of
Yeah.
something useful, though.
yeah,
That
and
won't be that useful.
probably not. And you realize that the way they design programming languages isn't from, would this functionality be useful? Let's make that, let's only create the language if we can think of a specific purpose for that. What they do is they try to write the languages so that they can encompass any situation. And so I can't think right now when I need the last 3 elements of something. I need to retrieve that.
First, do you feel like you're seeing MID, you know, the first 7 of your last name?
Yeah,
Extract what these values are.
Yeah, but then you still know what the given length is, though.
Well, no, it could be, your last name could be 1,000 characters long, you're only going to make your email address so long, it needs to be 7 characters to extract what's from
yeah.
it. So,
And if I'm doing web scraping, I'm probably going to get into that much more because I'm digging through some data that I may want the end of something, I may want the beginning of something. Yeah, I can't think of a specific use at this point. I can guarantee you though that if you do a lot of programming, at some point you will find a lot of stuff that you'll say, oh wow, I didn't realize that I could do that, but this, thank goodness that's there, it solves my problem. That'll happen all the time. Make sense as far as how it works? So let's open up listing 2-2. And that one says split up a URL of the form http www.something.com. So we're going to, it's going to get a ROM, but please enter a URL, and then it stores in this variable called URL. What type of object will this be that comes in? String. So we're going to get it in as a string, which is a sequence of characters. And then we're going to say domain is equal to URL 11 to -4. I guess this is a good example. Or no, this is. So, and then it's going to say print the domain name. http:// or www. So I got to see what this will do. Okay, so it's going to skip, I think, all of the characters and just get the www part.
Suppose just the, so suppose just Google.
Yeah. So go ahead and run it and type in http://www.python.org. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then, yeah,
All just Python.
should just say that, right?
I mean, based on what we were talking about earlier, I mean, that domain could be 50 characters long, you don't necessarily know.
Yep.
You just know that there's gonna be a .org or .com, .gov.
So no matter what website you put in there, it's gonna remove that and give you just the website.
Right.
So now though, there's just .us, whatever.
True. Now we have some,
Yeah.
this worked in the 1990s, I think.
Yeah.
But maybe there's some issues today. In reality, what you would look for is that dot, and we haven't gotten there yet. but it kind of gives an example. On the other hand, maybe you're working with a set of data where all of them are all .org sites. And maybe this is just being done to kind of make in an anchor tag, you just want that one little, you just want to say Python and then make that, and you're going to dynamically create a link. This is Python, but that will be the whole thing will be the actual link address. You just want to show Python. And it's going to go to the database to grab all those rather than doing it kind of, all hand coded. Make sense? Does that work? Domain name is Python. Inclusive, exclusive. So let's look at our if you still have that one open, you should still have numbers in there. And let's say we say 0, 10, 1. What happens with this? Everyone get that? So we do get, and we do get them all. So that's the same. The last parameter here, this last one, is the step length, which tells Python how many elements to skip each integral. If it omitted, it defaults to 1. What happens if you put 2?
Would we get it with 2?
Did we get that? So you see we can add a step length here in order to get every second element, every third element, every fourth element. So the other thing too is realize that we're doing this all with string, which is a sequence of characters. We can do these slicing operations with any kind of list. So if we had a list, if we applied it to a list of numbers and we wanted every other number, then we could do that. Let's say we wanted to we had a list of indices of students and we wanted to grab every third one and they would all go in one class. Every second, the second one, would go in, and then the first elements would go in the second one. We can use slicing to kind of break a list apart into 3 lists and kind of break up the elements that way. So there's a lot of areas where maybe you want to skip over a certain number of elements. You may have brought in some data that's actually delimited in a certain where the first element is an index number, the second element is a piece of data, and there's another index, then there's a piece of data, another index. You could use that to kind of skip over pieces and make a list of all the indices, and then another parallel list which has all of the data. So you can use that to do that sort of thing. If we do 6, 3, 6, 3, what do we think will be selected? This one, just try to figure it out. So what's the first number going to correspond to?
1, 2.
It'll be this element here, right? So it'll be that element there. The 6 is going to be, is 3, 6 include the 8 or not? So if we just do 3, 6, it would be 2, 3, 5, correct? And we're going to do the third element. So we get the 2 for the first one, and then but then the third one kind of jumps over it. I'm thinking we just get a 2. What do we get? We just get the 2. See how that kind of... So you just have to remember what's inclusive, what's exclusive, what you're skipping over, and the fact that you start at 0. You just have to keep all that in your mind at one time, and this thing is simple. And then what happens if we go colon, colon 4? So what's the first element going to be?
0.
Yeah. What's the last element going to be? Yeah, all the way to the end, right? So if we just had, if I hide this, which I can't because if we just had that part there, we would get the whole list. But it says get every fourth one. So I think we're going to get the 0, then we're going to get the 3, then we're going to get the 21. Does that work? Yep. So, same sequence, try, and you should still have it in memory, so it should work. Do 8 colon 3 colon minus 1. What's a minus 1 in the sequence? Well, it's not here in the last digit. It's not a minus 1 here. It's a minus 1 in the step over. So what does a minus 1 step over do?
Backwards each one.
Versus the order.
Yep, it reverses the order. So the 8th element is here. The 3rd element is here. It didn't. Why didn't it display the 2? Even though even though the first element is at the end and the last element is at the beginning, the last element here is always exclusive. So it's inclusive and exclusive there. So it didn't show the 2, but it did go backwards, 21, 13, 8, 5, 3. Make sense? And then if we do minus 2, you'll get backwards in pairs. So 34 goes here, the 13 goes there, then we skip over to the 5, then we skip over to the 2, then we skip over to the 1.
I'm confused with that one. Numbers, minus 1 there, because if you do numbers minus 1, you get 34.
Yes, but it's not in the 3 is actually the last.
All right.
And so it has a different effect in that. Make sense? And then here, if we go 0, now notice that here we started with with something down the line, and then normally this is lower than that, but we started to the end of the line going back. Here we're starting with 0 and then going to 10 to the 10th element and saying minus 2. We get the empty set. So if you're going back, if this is in the minus sign, the first number should be larger than the second number. Does that make sense? Because you're going from, in order to go backwards, you have to go from here to here. And so normally, if I was going to go from 2 to 8, first number would be 2, then 8. If I'm going from, in this case, 8 to 3, this becomes the first number, and that becomes the second number. Does that kind of make sense? It's kind of logical, right? If I'm going to count backwards, I should start at the higher number, and then the last number should be the lower number. So if I do it the reverse, I'll get an empty set. And I suspect some people have gotten frustrated with that.
How should you get an error? Because I just typed in numbers 34, which is larger than the larger index, like 10 is larger than what's there. But I get an error.
That's because when it tries to do the 34, it tries to grab the 34th element, and there it says, oh, I have run out of space in memory. But when I say 10, 10 is in the exclusive spot, so it wasn't going to grab 10 anyway, it's going to grab 9. And so it successfully grabs the 0. Then it says, give me the 10th element exclusively, which means I'm going to grab the 34. And then it says, then try to count backwards. Well, okay, we're starting at 0 and counting backwards. Okay. Whereas, so that's how its computer brain is doing it. And what's really happening is all of these examples, there's the same piece of code which is doing that logic for all of them. And so it's the reason why you see that behavior is because it's doing it the same way. Like our minds are flexible enough that we can actually say, oh, I should probably start at 10 and work backwards.
And so our human brains can do that, but the computer just applies a very rigid algorithm. That's why it kind of does these things the way it does. And then here, what does it do with this one? This one will actually figure out that it wants you to start at the end and work backwards. So here we say, beginning is everything, end is everything, and do it in -2 increments. Make sense? So how hard do you have to think about this stuff? You know that these things do things a little differently. When you're trying to do a sequence or a problem with a sequence, what I recommend is you write your sequence the best you can, you see what the results are, and then you test it to see if it gives you what you need. If it doesn't, then you go back and think, okay, maybe I just didn't put everything in the right spot. You may need to adjust things backwards and forwards by one to get them to get the actual value you want. And then once you've got that tested, then you go on with your code. So you don't have to know this stuff, like really at all times. You just need to know that you do have to sometimes tweak or adjust your slice indices in order to make them work the way you need them to. And then another one, 5. So we're going from the 5th element all the way to the end, -2 increments. It's actually going to say, well, since we're going -2, that must be from the 5th element all the way to this side. And so it gets the 5 because that's inclusive, and it goes to 5, 2, 1, and then I can't get anything chucked out. And this one is kind of the reverse of that. Get the 5th, everything from the end all the way to 5. So it's going to be 9, not including 5. So 34, 13. It doesn't grab the 5 because, of course, that element in the second block is exclusive. Make sense? So what I recommend is go look through these examples and play around with them. Maybe write a bunch of sequences in the interpreter and see what comes out. Write the sequence, try to visualize what it's going to be. Maybe write it down on a sheet of paper and then run it, and then until you kind of get a feel for it. So adding sequences, and we did this in the other example. What happens if I put 1, 2, 3 plus 4, 5, 6? I can see about a number of different things happening with that. Maybe I get 4 plus 1, 3 plus 2, 6 plus 3, or maybe I get, a list with 2 lists in it. But what this will actually do is concatenate. So if you add 2 lists together, it concatenates the lists together, and you get one list with all the elements in it. Does that make sense? And we did that with our example. Strings are sequences, correct? So if I add these 2 lists together, or if I add 2 sequences together, and I get a list, if I add 2 strings together, what do I expect? One sequence with all the elements in it. So it just does concatenation. And that's actually how Python is doing concatenation with your strings, like we're showing up here. It's actually just treating them as 2 lists, and it's doing this operation on it. It treats it the same way as it does any other list. If I do a list plus world, what's going to happen there? That's not as obvious, is it? Give it a try. Tell me what you get. Give you an error? Yeah, it can't combine lists of different, it can't combine sequences of different types. So it can only concatenate list, not string to list.
Those are different.
Yeah. And the errors are not bad. Some languages have errors which you're looking at and you don't know that a human actually wrote this. But these look like someone tried to make them meaningful. So, string sequence concatenation makes sense? Plus operator? Then the other thing we can do is multiplication. What happens when we multiply Python times 5? And we saw that with THs, right? What do we get? Python. You say 5 times fast. So yeah, you can multiply. You can make, and that's useful because if you want like 50 spaces after something, and then you could actually say 50 times open quote space close quote, and just say give me that times 50, and it'll do it for you rather than having to sit there at the keyboard. So 42 times, so here we have a 42 in a square brace times 10. Knowing what the sequence does with stuff like this, what do we think that 42 times 10 in this nomenclature will yield? How many say 420? We get a list of 10 42s. So that can be useful too if you want to initialize data and you want everything to be initialized to 0. You say that you can make a list of 1 0 and say give me 42 times that, so I have a list of 42 zeros waiting for me to throw things into those positions later on. So here's a problem. What if we want to create an empty list of 10 items? Again, we want to have some space holders. If we put 2 brackets, what will happen is we will actually get just an empty list. So that doesn't give you 10 spaces, and sometimes that can be a problem because if I have an empty list, what happens if I say put something in for the 10th element of an empty list? It gives you an error because it doesn't have a space for it. Oops. So what we do is there's a special element called a none, and that's actually kind of a space in memory or an address in memory, but it doesn't have anything in it. And if we say, give me 10 nones, and then we display sequence, you'll get this list with all these nones in those positions. And that's very useful because sometimes 0 means something. So if I was going to say, give me the temperatures for the last 12 months and make a list for it, and I had to put the data in there. If I put zeros in there, it meant that we had 0 degree. Does that really mean we have 0 degree temperature in Albuquerque every month of the year? Probably not. So if I want to initialize that list and I'm waiting for data to come in, I'm probably better served to put a none in that position, because if I can then check, and if I have none, it means, okay, I don't have any information. I need to wait for information. If I get a 0, some other part of the process may do that, and then we have vehicles trying to shovel snow in the middle of August in Albuquerque. Probably not. Usually there's humans somewhere then. Make sense? So if we look at the scene 2-3, trying to create a box, this is an example of where we want to create a box around a sentence. So we're going to get a sentence from the user, and we set some variables. And this is something we do a lot of times, is rather than hard coding numbers throughout the program, we'll use a variable and set the value once into this variable, and then use it throughout the rest of the program. So we know that our screen width is 80, and our text width will take the sentence, and this is a new function that you haven't seen before. len will take a sequence and tell you how many elements are in the sequence. So if you have elements 0 through 9, len will return 10. It's not, you don't have to worry, it doesn't do the zero-based thing. It actually tells you the number of elements in it. And then, so if you want to get the last element, it's really the len of that list minus 1. Luckily we have a minus 1, so you can imagine how it's actually doing this stuff. The box width will be the text width plus 6, because we're going to add 6 to we're going to add 3 characters on either side. And then the left margin will be the screen width minus the box width. And what's this double slash doing? It's forcing integer math. So it wants to get rid of any kind of a marginal value. So it forces integer division here. So it's going to take the screen width minus the box width, and then divide that by 2 to see how much space you put at the beginning and the end of that box, because we're doing this by printing out on a screen. And so here what we see is we print an empty line, and then we print a space times left margin. So right there, there's a sequence that's going to say whatever the left margin number is, that amount of space you want to put at the beginning, multiply that, give me a space character times that many. And now I'll space out the right number. Then it says give me a plus for that first corner, and then give me some minuses times the box width minus 2, because it's subtracting out those 2 characters, and so it's going to draw some lines across. Then it's going to put this last plus, and it's going to go back over here, whatever my left margin is, that many spaces, then put a vertical, then another space, then whatever the width of the text is, so I have some empty spaces to there, then a space and an end. Then it's going to keep doing, if you look at the code, it's going to keep going through and doing those types of prints. So if you look at that code and run it, type in something and tell me what you get.
I could have used this to make that interface instead of my little ASCII dots. I could have used this to do it.
Yeah, it's basically doing that same type of stuff. There's there's the first line, then there's all the spaces that are calculated out that need to do here, then there's the plus, there's all the dashes that calculated out. By taking the length of the sentence and adding some numbers, and there's a plus, there's that first dash, and then space that we did, and then the rest gets displayed out. If you dig through the code and just kind of trace through it, you kind of see what it's doing. Make sense?
Yeah.
And that's using the multiplication and you can multiply a sequence by a number to get some stuff spaced out. So we saw that. Here's the rest of it. You can see here where it's doing get the spaces on the left, get the left thing. It's displaying the sentence, and then displaying the other. Notice how they space things out to kind of make it easy to read. That's good. That's a good technique, and that's how that will work. Let's see, how many more? We've got 2 more slides. Okay, so then we can use the index method here. Let's say we have nights. We have a list, which is a list which contains multiple strings in it. We are the nights you say ni. By the way, Python comes from actually was named after Monty Python, a comedy group in Britain. So there's some references in your book to that. And if we say, Knights, give me the index of who, what do we think this is going to do? Yeah, it's going to look through this sequence, try to find where something that matches this criteria is. It finds who there. It'll probably give us, what do we think the number they'll return will be? 4. Exactly. 0 index, 1, 2, 3, 4.
So is Idle from Eric Idle?
What's that?
The Idle, is that Eric Idle, one of the actors?
I don't know. Maybe. I now need to find out. Herring. Are there any herrings in? You get an error if you look for a herring. But that's useful because you can use that, you can get an index for something you're looking for, then use that index in order to slice something to get what you want after that index. So you'll combine those. We can also create a sequence of sequence. Let's say Edward equals Edward Gumby, comma, 42. That's a list with a string in it and a number. You can combine, your list doesn't have to have all the same type. It can combine types. Then we say John equals John Smith and 50. And then we create this database which has Edward and John in it. So this is a list which has Edward and John in it. Edward is a list which has Edward Gumby and their age, presumably. Maybe a mailbox number or something. John is John Smith with the number. And now if we look at database, you'll see that what you get is kind of this nested list. You have two lists inside of a list. So you can have lists inside of tuples, inside of lists, inside of etc. Make sense? And if you think about it, the strings themselves are sequences too. So this is a sequence inside of a sequence, which is also inside of a sequence.
There's a lot of sequences.
Yeah, and you use this a lot. This is actually how you would structure a database, maybe type object, where you wanted to be able to navigate through. You want this one thing that you can pass around, but then you want to be able to dig into it and get information. And so that's what we're going to look at. And then the next time we'll look at how we get into this stuff. Any questions on what we showed so far? To upload stuff to to Blackboard, what you can do is if you go to Python, since we didn't really make a program today, just go to any one of your windows that may be open and just say File, and if you say Save, you can actually save your work on an interpreter, and you can just upload that. Question?
One thing you didn't show us was how to print a line with text and the number.
That's actually here. That's a good question. So how do I display, like, let's say I have a number, equals 3, and then I have some text equals some text. I'll show you in a second. So I could say print text plus, and I need to convert that number to a string. So we put str, and then we put the number we want to convert.
Okay. What does REPR do?
Was what?
REPR?
REPR? Let me see.
There's some other function they have in the book.
So looks like it's similar to str.
Yeah.
And let's give it a try and see where the difference is. So if I do so that's working the same as str. Okay. But let's see what the difference is, because obviously there's something. So str function is meant to return representations of values which are fairly human readable, while REPR is meant to generate representations which can be read by the interpreter or force syntax if there is no equivalent syntax. So some slight differences in how I think the machine replay references to it.
So for today's training, do we just submit some output there?
Yeah, just grab anyone, whatever shell you got left, and I'm not too worried as long as I just want to see.
No, I didn't get how you actually save it to the Blackboard though.
So here's, I'll give you an example here. So I go to File, and I'm going to save that, and it.
You would save as.
Yeah, save as, and let's say I called it, today's work, and I'm saving it to the desktop. Then you go to Blackboard, and then I have class here, and then you can come in here and say browse my computer, go to the desktop, and just grab that. and just upload it.
Signal scrub.
What's that?
Signal scrub.
Yeah, whatever you have in your shell. If we don't do any programs, then just upload that. That lets me know that, yeah, you kind of followed along and worked on it. Great, that's all I have for today. If you have any questions on your programs, let me know.
Okay.
So, okay, we've got input into the base, the height, and then print based on height. So what you could do is you could do this. Print area is, and then put that calculation in that string, convert it, that calculation to a string, and concatenate it.
Do I need to do floats on my input?
This already makes it a float.
Okay, that's what I thought.
And then that will make sure that this is done as an integer, I mean, as a floating point division.
So because I have my float there, and I thought, well, I can just do this, and I have that float there.
And then often what I'll do is I'll do my math and put a result in a variable, and then I'll display it that way, so.
Okay, so then I have to do a string on my result?
Yeah, rather than printing here, just say result equals that. Or you can. We got close string
Plus
the str.
Okay.
Make sense?
Yeah.
Thank you.